Let's do some more chain rule practice. How about the derivative of e to the negative x? That's exponential decay. That's really important stuff. We should be able to take the derivative of it. So go ahead and try to write out the chain rule. What's the inner thing? What's the outer thing? And then I'll do it. All right, so I would say the inner function here is negative x, and the outer function is e to the stuff. And maybe that's not so clear, like how is the stuff inside the e? It isn't exactly. Another way to think of e to the stuff is using the notation exp, just like sine or cosine. Exp of stuff. Again, if you wanted to be more formal, you could say e to the u or exp u. So that's all ways of thinking about defining the outer function here. So then we'll do, so let's go back, e to the negative x prime is d outer times d inner, or we could write it again, f prime of g of x times g prime of x. Both ways are good. So what's the derivative of e to the stuff? It's e to the stuff, and what is the stuff? It's negative x. And then what's the derivative of negative x? Well, we're getting e to the negative x times, that derivative is negative 1. So we could even collapse this to negative e to the negative x, or you could think of it this way. Let's graph it. E to the negative x looks like this. That's our original function. And our derivative is like exponential decay, but upside down. So it's doing this. And have you ever seen that before? Well, that was actually on the FDQ, BDQ, CDQ homework. And we asked, what does the derivative look like? And some people said it looks like a log function, which it kind of does, but we know this will always stay negative and a log function would go positive. Also, a log function would never go back past the axis here. Other people said it might look like an upside down 1 over x or something, which it kind of does, but again, that would have an asymptote here. But this can keep on going back toward negative infinity. Let's try another one. Let's do 3x plus 2 to the 100. And what's the derivative? Well, you don't really need the chain rule here. You could multiply this all the way out. If you learned the FOIL acronym, you could FOIL this 100 times, get a nice polynomial with 101 terms, and then take the derivative of each of those. But maybe the chain rule will save us some effort. So go ahead and spot what's the inner function and what's the outer function. Okay, got your guesses written down? So I'd say the inner is 3x plus 2, and the outer is stuff to the 100. Or if you want to be formal, u to the 100. Okay, so then the derivative would be d outer times d inner, or f prime of g of x times g prime of x. So what's the derivative of stuff to the 100? Should be 100 stuff to the 99, right? So 100, and what is the stuff? 3x plus 2 to the 99. But we can't stop there. We have to do this times the derivative of the inner function. What's the derivative of 3x plus 2? Well, at least write that that's what I want to do. So then I get 100 3x plus 2 to the 99. Derivative of 3x plus 2, you could say it's 3 times 1 plus 0. Or you could just say it's 3. Either way, if you can take the mental shortcut to say the derivative of 3x plus 2 is just 3, that's fine as well. I'm just trying to be a little extra formal here. All right, so that didn't turn out too badly. Certainly didn't have to FOIL out everything. Let's try a new one. Let's try 3 cosine x to the 5th plus 2 to the 100. Okay, so go ahead and spot your inner and outer functions. Pause the video, do all the work. Okay, welcome back. So I'd say the outermost thing, we don't always have to say what's inner first. We can say the outermost thing is stuff to the 100, just like before. And what's the inner thing? You can think of the outer thing as like the last thing that would happen in terms of order of operations other than basic multiplying and adding. So anything nonlinear, the last nonlinear thing that happens, that's usually your outer function. The inner function would be everything inside the parentheses. So that would be 3 cosine x to the 5th plus 2. All right, so then we'll do, we got to save some room here. D outer times d inner, or you could say f prime of g of x times g prime of x. Well, just like before, our outer is stuff to the 100, so the derivative of that is 100, all that stuff, 3 cosine x to the 5th plus 2 to the 99, and then times the derivative of the inner stuff, so we'll write the inner stuff here, 3 cosine x to the 5th plus 2 derivative. Okay, just like we did there. Now we just have a slightly more complicated thing. So how do we take the derivative of this? We've got a cosine x, and then we're taking that to the 5th. So it sounds like we've got a function inside a function, and we need to use the chain rule. So that's where our paper chain comes in, right? We had the original, we had kind of d outer, and then we linked on d inner, and now there's going to be a d inner from that even. So that's our metaphor for the day. Just a sec. All right, so maybe you've been puzzling what's going to be the outer and inner function here. So let's think if this was just an x, then I would know how to take the derivative. Just derivative of 3x to the 5th plus 2, that's a polynomial, it's pretty easy. So it's the fact that there's a cosine inside the 5th power, that's what's causing the trouble. So we'll say that the inner part, so this is all applying to that, the inner part is the cosine x, and the outer part is everything that's happening to the cosine x. So it would be 3 stuff to the 5th plus 2. So now I have to apply the chain rule to this. I'm going to just copy this part. That stays there. And I'm going to do times d outer times d inner. Notice it's getting complicated now because f and g are no longer what they were up here. They're now this. So I'm not even going to write f and g. So I'll still have this times, what's d outer? What's the derivative of 3 stuff to the 5th plus 2? That would be 3 times 5 stuff to the 4th plus 0. Just kind of using the power rule on stuff. And what is the stuff? It's cosine x. And then what's the derivative of the inner stuff? Derivative of cosine x. That at least we know how to do. So it's this times this again times negative sine of x. So we ended up with a 3-link chain kind of. Derivative of the outer, derivative of the inner, which then ended up having another inner tacked onto it. All right, so that's why it's called the chain rule.